Hello everyone, myself Danyashri Baby. Our topic is manual temperature checks are inefficient. An IoT system can track and alert users when condition exceeds safe levels. Here is the simulation of our project. ESP32 board. This is the main controller. All sensor buttons, LEDs and the display are connected to it. Potentiometer used as a temperature sensor. One middle pin goes to GPIO32 of the ESP32. The other two pins go to 3.3 volt and ground. Turning the knob changes the voltage. ESP32 read it as temperature button. One side of the button goes to GPIO30, the other side goes to GND ground. Uses to reset stop the alarm. LED green LED normal is connected to the GPIO27. Red LED is danger connected to the GPIO26. Then negative pin go to GND through resistor. Buttons buzzer positive pin goes to GPIO14, negative pin goes to GND. Make sound when temperature is too high or too low. 12C LCD display shows the temperature reading. Connected to ESP32 12C pins. SDA GPIO21, SCL GPIO22. Also connected to 5 volt or 3.3 volt and GND. Ground power connections. All components share ground to with the ESP32. ESP32 supplies power to LCD and other parts. The potentiometer gives a temperature value. ESP32 reads it, LCD shows it. If it is too high or low, red LED plus buzzer turn on. Button resets the alarm. Thank you. Next, continue by Siri.
Hello, I am Siri. Now I tell about temperature monitoring system. In this project we use ESP32 on the walkway simulator and connected to Blink Cloud for real-time monitoring. In the walkway circuit, the ESP32 collects data from sensors such as temperature. The values are processed and displayed on the 16:2 LCD. Will LEDs and buzzers indicate abnormal health condition like high temperature. The ESP32 sends these sensors value to the Blink cloud through Wi-Fi using virtual pins. On the right side, the Blink dashboard visualizes the live data through for temperature. It also includes an alert indicator and control buttons for the remote actions. The dashboard updates instantly when the walkway simulations generate to new values, providing the device is successfully connected to the cloud. Overall, the system demonstrates how IoT monitor virtual health parameters remotely and provide instant alerts, making it suitable for patients monitoring and emergency response sensorily. Next, continue by Madhura.
Hello everyone, I am Madhura. I am explaining the code part. Define blink print serial. This tells the program to show the blink connection messages in the serial monitor for debugging. Define blink auth token. This is the blink identification number. It allows ESP32 to connect to the own blink project. Header files include Wi-Fi.h, include blink simple ESP32.h, include wire.h, include liquid crystal I2C.h. Wi-Fi.h for connecting the ESP32 to the Wi-Fi, blink simple ESP32.h for connecting the blink app, wire.h for I2C communication, liquid crystal I2C.h to control the LCD screen. Wi-Fi configurations, car SSID, Wi-Fi guest, car pass ID, pass. These stores the Wi-Fi name and the password. ESP uses this to access the internet. Define POT temp 32, define button pin 13, buzzer 14, LED normal 27, LED danger 26. This makes pin usage easy, using names instead of numbers. POT temperature for the temperature input. button pin for the reset button, buzzer for alarm, LED normal for safe indication, LED danger for danger indication. LCD declaration, liquid crystal I2C LCD 0x27 16,2. This sets the LCD address 0x27 and the LCD size 16 columns and of 2 rows. Temperature limits, the threshold limits of limit values are 38 for 38 degree danger, and below 35 degree shows danger. Status variables, bool alarm active false, bool header printed is equals to false, bool last alarm state is equals to false, bool show cause is equals to false. The unsigned long last read millis is equals to 0, unsigned long last display millis is equals to 0. Alarm active for the alarm on or off. Header printed for print CSV header once. Last alarm state to detect the state change. Show cause to toggle display. Last read millis to control sampling. Last display millis for control LCD refresh. Danger cause stores the alarm reset. Blink virtual reset button. Blink right, this function resets the blink right Wi-Fi if parameter as int alarm active equal to false. This function runs when the button Wi-Fi is pressed in the blink app. It turns off the alarm remotely. The next part of the code will be explained by Lasya.
So, hello everyone, this is Lasya P. Shetty. Here is the explanation of the loop function. The loop function controls the entire operation of the temperature monitoring system. It manages temperature sampling, danger detection, alerts, user input, LCD updates, and communication with the Blink IoT dashboard. I will break the logic into stages. Firstly, the Blink runtime, blink.run off. This keeps the ESP32 connected to the Blink cloud and process incoming commands. Without this call, dashboard would stop receiving the updates and remote reset would not work. Nextly, the serial header. It will be printed only once. If not header printed, serial.println timestamp, temperature. This prints the column header only during the first loop run. This makes the output to look like a proper CSV file, which can be used further in the analysis of the output. Nextly, we having a read sensors, which is every second. If millis of minus last read millis greater than or equal to 1000, last read millis is equals to millis of. This code avoids the delay and uses millis of to run the sensor reading every 1 second. This ensures the system remains responsive, blink keeps running, LCD updates stay smooth. So nextly, we will be having a temperature reading and conversion. Float temp is equals to analog read of potential temperature into 12 divided by 4095 plus 30. It reads the analog value which is in between 0 to 4095, converts it into temperature range from scaling, adds a base offset of 30 degrees Celsius. This creates a realistic temperature values while using a potentiometer as a simulated sensor. The value will be printed as serial.print temperature reading, that is TS, serial.print comma temperature will be printed in the after comma. Next is the danger detection. We will be having the bool danger is equals to false and the empty string of danger cause. If temperature is greater than temperature high or temperature is less than temperature low, the danger will be turned to the true. So the danger cause will be having a string of temperature out of range. If the temperature goes beyond 38 degrees Celsius or below 35 degrees Celsius, danger is triggered and the cause message is stored as temperature out of range. This message is later shown on the LCD. The manual reset using button. So if digital read of button of pin is equals to low, then the alarm active will be set as false. When the user presses the push button, alarm is immediately turned off. LED and buzzer will update accordingly. This is local override capability. Nextly, the activating alarm if danger exists. If danger alarm active is equals to true, any dangerous reading automatically turns the alarm on. If the reading is going beyond the limit, then the danger will be set as true. So the alarms will, uh, will run until the temperature returns to normal and user resets via button or the blink dashboard. Nextly, the updating the outputs. The digital write will be LED danger alarm active. Digital write LED normal not alarm active. Digital write buzzer alarm active. Alarm will be on when on that time the LED red LED and the buzzer will get on and the green LED will in the off condition. If alarm is off, then the green LED will be on and the red LED and buzzer will be in the off condition. This is a simple and effective feedback system. Sending status to Blink app, blink.virtual write. Then the V4 pin will be in the alarm active state that the alarm LED in the widget will be turned to 1. Blink.virtual write, we do danger. The danger indication of the status will be get on. The app receives alarm status danger indicator. This is how the dashboard system synchronizes with the hardware. Reducing the LCD flicker. If alarm active is not equal to alarm last alarm state, LCD dot clear off. Last alarm state is equals to alarm active. The LCD is only cleared when the alarm state changes. When it is comes from state safe to danger, this prevents unnecessary blinking and improves readability. Updating the LCD every 1 second. If millis of minus last display millis of is greater than 1000, last display millis is equals to millis of showcase is equals to not showcase LCD dot clear off. This LCD content updates once per second. During danger, it alternates between the two screens like danger and also the safe. LCD messages shows either the cause of danger or the temperature with danger detected. If alarm active, if show cause, LCD.set cursor will be set to the first line where the cause string will be printed. In the LCD, the second line, it will print the danger cause and it will alternatively changes with the else block. Here LCD cursor for the first line danger detected and also in the second line we will be printing the respective values in which the danger is detected. In the else condition, that is in the normal condition, the status will be set as safe in the first line and the corresponding values will be printed. This is all about the code. Thank you.